guys, sum number 4, something different. You'll enjoy it. Apart from 3 problems which we did in superposition, this is something different. Please make it very careful. If you observe in this network, you have 3 sources. This is your dependent source. This is your dependent source. This is your This is your independent source. This is your independent source. This is your dependent source. Because superposition says the number of dependent source while solving an inverse if you have. So this clearly says to you that you have 2 independent sources. So you need to solve 2 cases. And ultimately I need to find Vx. So let's do it. In case 1, acting 20 volts. If 20 volt is acting, 10 amperes should be removed. If I need to remove 10 ampere, it has to be replaced by its internal resistance. The current source internal resistance is infinite. That means I need to open circuit this current. If I need to open circuit it, this both branch will be removed. So your circuit will look like 20 volts, 2 ohms, 6 ohms, plus or minus Vx depending voltage, 4 ohms. Again, the current source Vx. So let's solve it. Ultimately, I need to find by Vx. This can be solved either mesh, either super mesh. So let's see which logic it can be solved. Make it sure this network should be drawn by you before further proceeding. So if I need to apply KVL in mesh 1, how many resistors we can see? There are 2 and 6. I hope you have drawn the network. So it will be 8. Current flowing is I1. So take it for because we are writing equation for that mesh. So make it 5. Other than I1, everything should be negative. Observe it if any the current is flowing. If you observe it carefully, I2 is flowing from 6 ohms. The sign will be negative. No other current is flowing. You write equal. After equal, you will be writing the voltage source. Observe the mesh 1 carefully, my dear. So your current enters into negative. So your equation will be positive. That will be your equation. Look at the second loop. In second loop, you have a current source. That means you cannot apply KVL. KVL, you do it to find current. If there is directly a current source, you get the value back. That means you will be getting the I2 value directly, right? Just check it. The direction of I2 and the current source. Is it same or is it different? Direction of I2 and the current source, same or different? You can observe it. The direction is same. That means the sign will be positive. So it is what Vx upon. So you got the relation of I2 and Vx. So let's observe where Vx is depending on. Because there are 2 unknowns, my dear friend, I1 and I2. There has to be Vx. So have a look where Vx is dependent. For finding Vx equation, you have to use Ohm's law. V is equal to I1. For V, you need to write Vx. For R, Vx is across which resistance, my dear friend? It is across 6 ohms. In 6 ohms, which current is flowing? There are 2 currents which are flowing, I1 and I2. I1 is entering into positive, so it is I2. I2 is entering into negative, so it is minus. So Vx will be 6I1 minus 6I2. Put the value of Vx in this equation. So your equation which you will be getting is I2 is equal to 1 by 2 as it is. This will be 6I1 minus 6I2. Simplify this equation, which what you get. So if you simplify it, my dear friend, you will be getting I2 is equal to 3I1 minus 3I2. Shift all the variable that side, so you'll be getting, my dear friend, minus 3I1 plus 3I2 plus I2 equal to 0. So we'll be getting minus 3I1 plus 4I2 equal to 0. That will be your equation number B. You got two equations, you got two unknowns. Simplify by using calculator. So you'll be getting, by using a scientific calculator, you'll be getting the value of I1 and I2. After calculating this value I1 and I2 by using a scientific calculator, ultimately we need to find Vx. The Vx equation is given by this. Let's put down the values I1 and I2 over here. We'll get the value for Vx. Since this is a case 1, so you just need to denote by V that. Now we'll be going for case number 2. For case number 2, friends, you'll be selecting 10 amperes. When you'll be selecting 10 amperes, you will remove your voltage source. And I say you need to remove your voltage source, that means you need to replace the voltage source by its internal resistance, that is nothing but 0. So you have to short the voltage source. So you have to short the voltage source. So in this case, you got three unknown currents, I1 and I2. So let's observe whichever current you'll be getting directly. So if you observe carefully, your I3 current you'll be getting directly. But let's see the direction is same or different. If you see the direction of I3 and 10 amperes, it is opposite. So it is opposite, so I3 value is nothing but minus 10 amperes. So let's have a look for I2. Again, you have a current source in this, so you'll be getting the value for I2 directly. I2 and this current source direction both are same. So the direction is same, that means I2 will be equal to plus Vx upon. Since we know it, when you apply KVL or when you put a new equation, the equation should be in terms of unknown. When I say unknowns, my dear friend, that I mean by I1, I2 and I3. That's it, right? So put the value of Vx in terms of current. So if I need to find Vx, my 5 friend, so use Ohm's law. So for V, you will be writing Vx. For R, Vx is across which resistance? 6 ohm. In 6 ohm, my dear friend, which current is flowing? I1 or I2? Yes, both the current are. I1 is entering into positive, so you will be writing I1 plus I1. And I2 is entering into negative, you will be writing minus I2. So that's the equation for Vx. Put the equation of Vx in this equation. You will observe your equation would be I2 equal to 1 upon 2, take it outside. Your Vx value you got is 6I1 minus 6I2. Simplify it, you'll get I2 equal to 3I1 minus 3I2. Shift all the variables towards left, LHS side. On RHS, there is the only number, only constant here. So you'll be getting minus 3I1 plus 4I2 plus I2 equal to 0. So your equation will be minus 3I1 plus 4I2 equal to 0. That will be your equation number. So let's observe for the KVL equation in mesh 1. In mesh 1, if we observe PV, there are two resistors. So you'll be getting 8I1. Observe it, in this two resistors, is there any other current flowing through it? Yes. I2 is flowing across 6 ohms. I3 is flowing across 2 ohms. Any other current apart from I1, you will take it as negative. So your equation will be 8I1 minus 6I2 minus 2I2. I hope you're getting it. So please, let's write the equation. So your statement will be applying KVL in mesh 1. We get, this will be 8I1 positive because that mesh equation. Next will be minus 6I2. Next will be minus 2I3 equal. Once I write equal to, after equal to, I just need to put down the voltage. In mesh 1, I don't have any voltages, so I'll be putting the values. Since I already got the value for I3 in the first case, so put on the value of I3 directly. So a value of I3 which you got was minus 10. So put in the value of I3, that will be 2 into minus 10 equal to 0. So shift the number towards RHS. So your value will be, my dear friend, minus 20. This will be equation. So you got two unknowns and two equations. Use your scientific calculator, get the value of I1, get the value of I2, put the value, the unit what you'll be getting is the amp.
After the calculation by using a scientific calculator, after getting I1 I2, you get ultimately you need to find, my dear friend, you need to find Vx. Your Vx will be the equation which you got is 6 bracket I1 minus I2. Put the value for Vx, my dear friend, put the value for I1 for getting Vx minus of minus 4.29 bracket close. So Vx which you will be getting, my dear friend, there will be minus 8.57 approximately. The value which you got in this condition is minus 8.52 volts. Since it was in second condition, so you'll be putting double dash. Ultimately, the question said find Vx. So there will be addition of both the cases. It will be Vx dash plus Vx double dash. So Vx is equal to first condition was 8.52 plus second condition was minus 8.52. So your Vx ultimately will be 0 volt. So that was your final answer for this. Again, repeating the same thing. While solving the sum, make it a point. You have the network, you draw the network for each and every case while watching the videos. That will really help you. Thank you so much, guys. We'll have one more sum for superposition theorem, then we'll be completing superposition theorem, and then we'll be moving towards Thevenin's theorem. Thank you so much, guys. Signing off.